Assalamualaikum and hello to everyone. In this video lesson, we will continue with chapter 4 of our syllabus. In this video lesson, we will be covering the fourth subtopic as highlighted on the left. For this video lesson, we will look at the reheat Rankine cycle under ideal conditions. The objective for the subtopic is on the right of the screen. To improve the performance for a simple Rankine cycle, number 1 is to pump the fluid to a higher boiler pressure, thus increasing its boiling temperature. Number 2 is to perform a reheating process inside the boiler and to expand the steam inside a low pressure turbine. The schematic diagram for a reheat Rankine cycle is shown in the figure given. And for an ideal reheat Rankine cycle, the TS diagram is as follows. For reheat Rankine cycle, state 1 is assumed to be saturated liquid and the pressures for the states are as follows. The temperature at state 3, which is at the inlet of the high pressure turbine, is the maximum temperature of the cycle. Now, for working parameters, using the steady flow energy equation, the working parameters for the processes involved for an ideal reheat cycle is as follows. For process 1 to 2 at the pump, the work input can be determined by using the following equation. For process 2 to 3 at the boiler, for primary heating, the following equation can be used to find the primary heating power. For process 3 to 4 at the high pressure turbine for the first expansion process, the following equation can be used to find the work output. For process 4 to 5 at the boiler again, for the reheating process, the following equation can be used for calculating the amount of heat added during the reheating process. And for process 5 to 6 at the low pressure turbine, for the second expansion process, the following equation can be used to calculate the work output. And finally, for pressure 6 to 1 at the condenser, we can use the following equation to find for the amount of heat rejected during this process. For performance parameters, to calculate the thermal efficiency for the cycle, we can use the following equation. Now, work net here is equal to the total work output minus the work input. For total work output, since there are two turbines, the total work output is the addition of both turbines' work output. For total heat added, we must add both primary and reheating heat addition process. For work ratio, it is the net work output divided by the gross work output. For specific steam consumption, we can use the following equations depending on the units provided. Now, let's look at an example for the ideal reheat Rankine cycle. You can pause to read and understand the question properly. Make sure to identify from the question the minimum, intermediate, and maximum pressures for the cycle. For step 1, please try to draw and label the schematic diagram for the reheat Rankine cycle. This can be done by referring to the related notes. For step 2, to find for total heat transfer, the following equation can be used. Total heat transfer involves both the primary heating and reheating components. To find the total work output, add both work output at the turbines. The thermal efficiency can be calculated using the following equation. Remember to calculate the ideal work input at the pump to find for the net work output. And finally, the specific steam consumption can be calculated using the following formula. For step 3, find the required properties at each state. At state 1, using the given properties, we can read for specific enthalpy and specific volume here at state 1. At state 2, Since the process is an isentropic process, therefore we can calculate the ideal work input by using the following equation, and subsequently we can calculate for the ideal specific enthalpy here at state 2. At state 3, using the given properties, remember to check the phase first and then read for specific enthalpy and specific entropy here at state 3. At state 4, since this is an ideal cycle, the expansion process from state 3 and state 4 is an isentropic process. Therefore, using the appropriate table, check for the phase, and using the appropriate table again, calculate for specific enthalpy here at state 4. At state 5, using the given properties, remember to check for the phase first and then read for specific enthalpy and specific entropy here at state 5. At state 6, since this is an isentropic process, using the appropriate table, remember to check for the phase. Now, since the phase is a mixture, we have to calculate the quality here at state 6, and then using the equation of mixture, calculate the specific enthalpy at state 6. We can then sketch the TS diagram for the question based on the states that we have already determined. For step 4, substitute the required values and solve for the question. For number 1, number 2, and number 3, and also number 4. Now, depending on the decimal points taken during the calculation, some might get different answers when trying to solve the question again later. If there are any questions regarding this example, please do not hesitate to ask me. We have come to the end of this video lesson. In the next video lesson, we will look at the reheat Rankine cycle under actual conditions. Thank you for your attention and have a good day.